To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Now we are going to start the third chapter of this lesson, children. That is melting point and boiling point. So in the previous chapters, we learned about the heat and temperature, how to measure temperature using thermometers, and how to make our own thermometer we learn, right? And also we learn about liquid expansion. Now we know that using the theory of expansion of liquids, we can make thermometers, and at the same time there are different scales that we can measure the temperature with, right? Now we are going to learn about melting point and boiling point. What is this melting point and boiling point? We'll go through this. There's a constant temperature at which a solid substance changes to its liquid state. So according to this one, when the solid substance changes to its liquid state, the temperature has been constant, which means the temperature does not change. Is this true? We are going to check whether it's true or not using this experiment, right? Here we have the activity. Finding out the constant temperature at which ice changes to water. We are going to check whether actually there's a constant temperature for the ice to change to its water, right? So what are the materials we need? We need some ice cubes. We need a thermometer. We need a glass funnel. And then we need a beaker. Let's write. Ice cubes. We need a thermometer. And we need a glass funnel. And a beaker. Ice cubes, a thermometer, a glass funnel, and a beaker. So how to do this activity? First of all, we will label this diagram. So whenever you draw a diagram, make sure you label it. So by drawing a diagram, we can understand the experiment better. Right. Beaker, glass funnel, right funnel, ice, and the thermometer. Right, children? So put some pieces of ice into the glass funnel and place the bulb of the thermometer in the ice, right? So you have to set the apparatus like this. You have to put some ice cubes to this glass funnel, and you have to immerse the bulb of the thermometer in between ice. So when you do this, you have to make sure the bulb is nicely covered with, surrounded with pieces of ice. Okay, children? Number 2, keep the funnel on the beaker like this and find the temperature of the melting ice. Now you know that when ice is taken out of the fridge, it starts melting because of the normal temperature outside, right? So at this time you will see ice starts melting. That water will be collected into this beaker, right? So while this ice is melting, we are going to check what happens to the temperature of ice, right, children? So we'll do this activity now. Right, children? Now we are going to observe what happens to the thermometer reading when ice is melting. You all can see how I have set this apparatus up. You all can see I have fixed this thermometer using the stand, and here a funnel and the beaker under the funnel. Okay, what I'm going to do is I'm going to put these ice cubes around this thermometer, right? Observe carefully what happens to the thermometer reading. Before we put ice, we are going to check what is the thermometer reading. So you all can see it is somewhere between 24 and 25. This is calibrated in Celsius degrees. Okay, right. I'm going to put this ice now. Carefully observe what happens to the thermometer reading. Okay. So remember, when we put ice, the entire bulb should be covered with ice. Right? So earlier the beaker was empty. Now if you observe carefully, you all can see the ice is melting and the water gets collected in this beaker. Right, children? Which means ice is melting. What happens to the temperature? Observe carefully. Now the temperature is at 0. Check whether it's going to change further, children. Now you can observe two things. The temperature is at 0 degrees Celsius, and at the same time you all can see this ice is melting. That is why water has been collected in this beaker that is kept below the funnel. Is there any change in the thermometer reading, children? There's no change yet. So ice is melting and the bulb of the thermometer is immersed in ice and the reading is at 0 degrees Celsius. This is not changing. What is the reason, children? Remember, when a solid is melting or when a solid is changing to its liquid, melting means solid becoming its liquid. Okay? So when a solid is becoming its liquid or changing to its liquid, throughout the time it's changing, the temperature is kept at a constant, which means without changing, the temperature of that specific solid is kept the same. Right? The specific temperature or the constant temperature at which a solid is changing to its liquid is known as the melting point, the specific temperature. Right? The specific or the constant temperature at which a certain solid is changing to its liquid is known as the melting point of that solid or that substance. Okay, children, which means from solid to solid, this temperature changes. Okay, so it depends on the solid or the substance. Okay, so when we consider a certain substance or certain solid, it has the same specific temperature while it is melting. Throughout the time it is melting, this temperature will be kept at a constant without changing. What is the temperature now? 0 degrees Celsius. And at the same time, we know that ice is melting, which means ice is changing to its liquid form, means water. Right, children? So, in this way, what is the conclusion? What is the melting point or that specific temperature of ice being converted to water, that throughout the time period, temperature is not changing? What is the melting point of ice then? The melting point of ice is 0 degrees Celsius. Right, children? Remember, while all the ice is remaining here, this temperature is not going to change. When all the ice converted to water, then what will happen? Then the temperature will increase, because we know that compared to ice and water, water's temperature is higher than that of ice. Right, children? Therefore, after doing this experiment, it's very clear that the melting point of ice is 0 degrees Celsius. Right, children? So you all observed what happened. So we did this activity. We placed the thermometer in between ice and we observed what happened to the reading of the thermometer while ice is melting. What happened, children? Did the reading change? No, it did not. Throughout the time we were observing this experiment, what happened? The temperature remained at the same value. What was the temperature? The temperature was 0 degrees Celsius. Right, children? The temperature was 0 degrees Celsius. It remained the same without changing throughout the time period. Right, children? So what is the conclusion that you can come up with after doing this activity? Which means while ice is melting, the temperature remains constant without changing. So we can come to a conclusion that the constant temperature at which this ice turns into its water, liquid, right? The solid ice turns to its water, its liquid is 0 degrees Celsius, right? So after doing this activity, sure, we can prove that there is a specific or constant temperature for the ice to melt. Right, children? Let's write that. So observation. While ice was melting, thermometer reading remain constant, and 0 degrees Celsius, right? While ice was melting, thermometer reading remained constant, which means without changing, at 0 degrees Celsius. So what is the conclusion? Right? We can come to a conclusion that there's a constant temperature where ice melts, right? Which means what is this constant temperature? This is 0 degrees Celsius, right? So here, according to the topic, finding out the constant temperature at which ice changes to water, right? So we can write the conclusion using that. There is a constant temperature at which ice turns into water. That temperature is 0 degrees Celsius, right? There is a constant temperature at which ice turns into water. That temperature is 0 degrees Celsius. Ice changes into water means change of states take place. Ice is solid, water is liquid, right? Change of states take place, right, children? Ice is melting means solid is turning into liquid, okay? So here it can be observed that the temperature at which ice is melting is 0 degrees Celsius. Therefore, the constant temperature at which ice melts is called the melting point of ice, right? There is a specific or constant temperature at which ice turns into water, and this temperature of ice is known as the melting point of ice. Melting point of ice. So you can write it like this. Ice is solid. It's turned into liquid. How does this happen? When ice is taken out of the fridge, what happens? Ice absorbs heat. So when you compare ice and the outside temperature, the temperature of outside is higher than that of ice. Therefore, heat transmits from environment to ice, right? Therefore, heat transmits from environment to ice, right? Ice absorbs heat from the environment, right? So, ice turns into water by absorbing heat. Absorbing heat. Right, children? So, ice turns into water by absorbing heat. So, here ice is a solid, water is a liquid. Right, children? Change of states take place. Solid turns into liquid. Okay, children? So what is the melting point? Then now we know melting point of ice means the specific temperature at which ice changes to its liquid. Okay, so melting point means we can apply this to just any solid, children, just any substance. So when you consider a solid, there is a specific temperature. When we consider different solids, at different temperatures, they will convert to its liquid. So while this solid being converted to its liquid, throughout that time, temperature will remain at the same value. This specific temperature is known as the melting point of that particular substance, which means from substance to substance, melting points are different. Okay, children? So the constant temperature at which a solid substance changes to its liquid state is known as the melting point of that substance. So for some substances, we have to provide more heat, a large amount of heat in order to melt it. Most of the time, metals act in this way. Only after absorbing a really large amount of heat, some metals start melting. But some other substances like ice, we don't have to provide that much of heat. Just taking out the fridge would be enough. Right, children? We don't have to exactly provide heat. It just absorbs the heat from the environment and it starts melting. But most of the metals are not like that. We have to provide heat. Okay, we have to provide heat, and then only, just by absorbing heat in the environment, most of the metals will not melt. Right, which means from substance to substance, this temperature that should be provided is different. Okay, so substance to substance melting points are different. Okay, so the constant temperature at which a solid substance changes to its liquid state is known as the melting point of that substance. Right, children? When water is cooled, ice or solid forms, we all know that. This can happen to the other way too. Let's say ice. Normally when you heat ice, ice turns into water. Even without heating, just by absorbing the temperature, right, by absorbing heat. By absorbing heat, ice turns into water. Right, ice turns into water by absorbing heat. At the same time, now this temperature is 0 degrees Celsius. At the same time, if we cool down water, what happens? Due to cooling down, water again turned into ice. If we reduce the temperature of water, if we cool it down, water will again turn into its ice. Right? It's solid. So by cooling down, this can happen. What is this temperature, children? This temperature is also similar to the melting point. Right, this temperature, the water converts to its ice also. The temperature is 0 degrees Celsius, and this is known as freezing point. Right? So when water is cooled, ice or solid water forms. The temperature at which water solidifies is also 0 degrees Celsius and is known as the freezing point of water. Which means the turning point of ice and water is 0 degrees Celsius. So when we consider a certain substance, its melting and freezing points are the same. Right, children? Its melting and freezing points are the same because it just converts from one state to another state through that particular temperature. So the temperature at which water solidifies is also 0 degrees Celsius and is known as the freezing point of water. Right, children? Okay, we'll move on to the next. Right, look at this table. The melting points of some substances. You don't have to memorize these things at all. Right, don't try to memorize them, but get an idea how it changes. Right, in this column it's given substance. Here it's given melting point in degrees Celsius at 1 atm. Atm is like this is atmospheric pressure. Right? At a particular, when the atmospheric pressure changes, these melting points can change. Okay? So you are going to learn about it in the upper grades. For now, just remember at 1 atm, when the atmospheric pressure is 1, the melting points of these substances. But you don't need to memorize these figures. Just get an idea. So what is the melting point of ice is 0 degrees Celsius. Melting point of paraffin wax. Paraffin wax, you know that when you have to heat up wax, let's say candle wax, then the moment you heat it up, it starts melting. But when you consider ice, do you have to actually provide heat from outside? No. When you just leave it in the environment, normal temperature, room temperature, it starts melting. But when you take a piece of paraffin wax, it's not the same. You can just keep a candle without melting under normal temperature. Only when you provide heat, when you light it up, it starts melting. So paraffin wax, you have to provide more heat to melt it, which means, example here given, 60 degrees Celsius. That value is 60 degrees Celsius. Right? Lead and iron. Lead and iron both are metals. Right? When you consider lead, the melting point is 317 degrees Celsius. 317 degrees Celsius. Right? When you consider iron, look at this, 1539 degrees Celsius. Right? Iron's melting point, which means in order to melt lead, a piece of melt, in order to start melting, you have to provide this much of temperature, right? This much of temperature to the piece of lead. When you consider iron, you have to provide the temperature of 1539 degrees Celsius in order to melt it. This is very high compared to the first two. Right, children? So by looking at this table, what is the conclusion that you can come up with? So compared to ice and paraffin wax, lead and iron's melting points are higher. Iron's melting point is the highest out of these four. Right? Lead and iron are both metal substances. Right? Iron is even harder than lead. Okay, children? So we can come to a conclusion that when you consider metals, metals have relatively high melting points than the other non-metals. Right? Metals have relatively high melting points. In order to melt metals, you have to provide more heat. Right? Therefore, melting points. Melting point means the specific temperature at which a certain solid melts, turns to its liquid. Right? So we have to provide more heat means melting point is higher. So after going through this table, I'm sure you understand that melting points of metals are higher than non-metals. Right, children? So we'll move on to the next. So our next topic is boiling point. So in this chapter, we are going to learn about melting and boiling points of substances. Okay? So now we know that melting point means the specific temperature at which solid substances, a certain solid substance changes to its liquid. Okay? So what is the meaning of boiling point? Boiling point is the next change of states, right? The boiling point can be simply explained as the constant temperature at which a liquid substance changes to its gaseous states, right? So, constant temperature. Constant temperature means this also does not change, okay? At which a liquid substance changes to its gaseous state, which means when a liquid, in order to turn a liquid to its gas, we have to provide heat. We will consider if this is water, in order to convert to its gas, which means water vapor. What do we have to do? We have to heat up the liquid water. So then what happens? Liquid water absorbs heat and at one point it starts boiling. The moment it starts boiling, this temperature is known as the boiling point of water. Right? Here also change of states take place. So we are going to do an activity to understand this better. So the next activity is finding out the constant temperature at which water changes to water vapor. Change of states take place here also. We are going to check whether there's a specific or non-changing temperature for this activity to happen. Right? When water change into its gas, we are going to check whether the temperature is going to change or remain constant. Okay? Right. So what are the materials we need? We need a boiling tube, a thermometer, water. We need a burner, Bunsen burner, or even spirit lamp can be used. Okay? And a laboratory stand. We'll write boiling tube. We need a thermometer. We need water, a burner, and a laboratory stand. A laboratory stand. Right, children? Boiling tube, thermometer, water, a burner, a laboratory stand. So how to do this activity? Look at the diagram. We will label this first. Thermometer, boiling tube, water, burner, laboratory stand. Laboratory stand, burner, Bunsen burner or spirit lamp can be used too. Spirit lamp. Water, boiling tube, thermometer. Right, children? Let's see. Take some water into a boiling tube and prepare the setup as shown in the above figure. Heat the water for a few minutes till it boils. So first of all, before you start this activity, before you provide in heat, you have to take the initial temperature. You have to check where the temperature is at. Right? So heat the water for a few minutes till it boils, and you have to, while you are doing this activity, you have to keep on checking what happens to the thermometer reading. Record the reading of the thermometer. So you have to check whether when the water starts boiling, at that time you have to check what the temperature is, and you have to check what happens to the temperature while boiling this water. Right, children? So let's do this activity now. Right, children. In the previous activity, we observed what is the melting point of ice. Okay, now what is the meaning of melting point? The specific temperature at which a certain solid turns into its liquid is known as the melting point. Now we are going to find out the boiling point of water. Now boiling point means the specific temperature at which a certain liquid turns to its gas. Okay, so when we watch this experiment, you will understand this better. Now you all can see I have fixed the thermometer here, and the thermometer bulb is well immersed in water. This is a boiling tube with water. Why do we use a boiling tube here? Because we are going to heat this setup, heat the boiling tube. So here we can't use a test tube because test tubes cannot withstand heat. Okay. Now boiling tubes can withstand heat. That is why in order to do this activity, we are going to use a boiling tube. And here we have a spirit lamp. You all can see the bulb is immersed. Bulb is completely immersed in water. So this is the correct method of measuring the temperature. The bulb thermometer's bulb should be completely immersed in the substance that we are going to check the temperature of. Right? Okay. Now, first of all, before we supply heat, Observe carefully. What is the temperature at the moment, children? You all can see very clearly. The temperature is 25 degrees Celsius. This is a Celsius thermometer. Right, children? Temperature is at 25 degrees Celsius. Now, this is the normal room temperature at the moment, right? Okay, now I'm going to light the spirit lamp, okay? Right, and I'm going to place this under the boiling tube. Observe what happens to the thermometer reading, okay? So now water starts to absorb heat. You all can see the thermometer reading increasing gradually. Now it reached somewhere 30. So now it passed 30 degrees Celsius. It's around 35 degrees Celsius now. Now it is at 40. And it is slowly increasing. You all can see very clearly if you pay attention. It's slowly reaching 50 degrees Celsius. And it passed 50. At the same time, try to look at the test tube, children. You can see the water's getting heated up and you all can see tiny bubbles too. Right, temperature is reaching 70 degrees Celsius now. And at the same time, more air bubbles in the test tube you can see, which means it's starting to boil. It's at 80. And now it's heating up very fast. You all can see the small bubbles. Now a lot of bubbles are there. And it passed 90 and water is boiling now. What is the temperature now, children? You all can see very clearly the temperature is at 100 degrees Celsius now, right? Check whether it's changing anymore, children. Now the water is nicely boiling. You all can see. We will check whether the temperature is going to increase more. Okay. Now what is the meaning of water boiling, children? Water's boiling means the liquid water is changing to its gaseous state. Right? That is why you can see the steam. Right? You can see the steam means water. This is water vapor. Right? Or the gaseous state. Right, children? So you all can see. Check again, children. What is the temperature now? It is still at 100 degrees Celsius, children. You all can see very clearly it is not changing beyond 100. You saw very clearly earlier when we started to provide heat, it was at 25 degrees Celsius and it gradually increased, right? Then what happens? Now when water started to boil, this temperature stopped at 100 degrees Celsius. Take another look, children. Check whether it's changing anymore. You all can see it is still at 100 degrees Celsius. Right, and water is still boiling. You all can see the level of water is reduced now, which means now earlier more water was present. Now part of the water is gone out as steam. Okay, children? Right. Right, children. So here what happened? Now you all can see earlier, observe very carefully. You all can see earlier the water level was above the level of the bulb. Okay, the bulb was nicely covered with water. Now you all can see the level of water has gone down even below the bulb, which means part of the certain amount of water is gone out as steam. Right? Throughout that time, did the temperature change, children? No. Temperature was remaining at 100 degrees Celsius. Right? While the water was boiling, the temperature was at 100 degrees Celsius. Now check what's happening, children. Is it still at 100? Now you all can see it is below 90 degrees Celsius. Right? It is between 80 and 90 degrees Celsius. You all can see clearly. Right? Which means now the temperature is dropping. That is because now we are not providing the heat anymore. That is why the temperature is going down. Now, what is the reason for the temperature remaining at 100 without increasing or decreasing while the water was boiling, children? This is another change of state taking place. Water's boiling means the liquid state of water turns into its gaseous state. Right? So throughout this time period, remember children, while the entire amount of water finished boiling, the temperature remains the same. It is not changing. Right? Do you remember when we were learning about the melting point? We learned that the temperature specific while a certain solid is turning to its liquid. In the same way, when a certain liquid is changing to its gas, the temperature remains the same, constant. Right? This temperature is known as the boiling point. So what is the boiling point again? The specific temperature at which a certain liquid changes to its gas is known as the boiling point of that certain substance. So which means the boiling point differs from substance to substance. Right, children? So you all observed what happened. What happened there, children? So you made the setup like this. And when initial temperature was almost at room temperature. And what did you observe when we started to heat this setup? What happens, children? The thermometer reading gradually increases. Right? The thermometer reading gradually increases, and at one point when that temperature reaches 100 degrees Celsius, what happened, children? Water started to boil. So while water is boiling, did the temperature change? It did not. It remained at 100. Right? Which means when we provide heat, the temperature of water increases. When the water starts to boil, the temperature does not change anymore. Which means while the water is boiling, the temperature remains at 100 without changing. So after doing this activity, it's very clear. Water is boiling means what's happening, children? When water is boiling, liquid water is changing to its gas. Right? So when water is boiling, which means when water is changing to its gas, the temperature remains at the same amount, 100 degrees Celsius. It's a constant value. Right? So this temperature is known as boiling point of water. Right, children? So we can make sure that water has a specific temperature when it's changing from liquid to its gas. Right? We will write this down. Observation. When heat is supplied, the thermometer reading gradually increases. Water starts to boil at 100 degrees Celsius. Temperature remains at 100 while water is boiling. So these are the things we observed. When heat is supplied, the thermometer reading gradually increases. That's the first thing we observe. Then we saw that water starts to boil at 100 degrees Celsius, right? And then temperature remains at 100 degrees Celsius while water is boiling without changing. Okay, so what is the conclusion? When water is boiling, which means change into its gas, change into water vapor. Temperature while water is boiling, temperature remains at 100. Therefore, the specific temperature at which water boils is 100 degrees Celsius. While water is boiling or changing to water vapor, temperature remains at 100 degrees Celsius. Therefore, the specific temperature at which water boils is 100 degrees Celsius, right? So, here it's given. It can be observed that the temperature at which water boils, with bubbles evolving steam, boiling, right, is 100 degrees Celsius. And it can be concluded that there is an exact temperature of boiling water, right? There is an exact temperature of boiling water, right? So here what is the change of states take place? Water changes to, now water is the liquid, changes to water vapor, which means the gas. Right, children? Water changes to water vapor, liquid into gas, right? So what is the boiling point then, children? The constant temperature at which a liquid substance changes to its gaseous state is known as the boiling point of that substance, which means the boiling point of water is 100 degrees Celsius, which means only when we provide up to 100 degrees Celsius of temperature, water starts boiling, water changes to its gas, right? So when you consider other substances, this value is not the same. From substance to substance, it changes. Okay, children, from substance to substance, this value changes. Therefore, when you consider a certain substance, it is a specific value. Okay, the constant temperature at which a liquid substance changes to its gaseous state is known as the boiling point of that substance. Right, children? So here we have another table, the boiling points of some substances. Again, you don't need to memorize any of these things. Try to memorize the water's boiling point because it's when it comes to science, it's kind of general knowledge. So try to memorize that one. We'll have to use it in the upper grades too. Right, but don't try to memorize the other things. Just get an idea how it changes from metals to non-metals. Right, children? So this column, it's given substance. Here, boiling point in degrees Celsius at 1 atm, at 1 atmospheric pressure. Right? Here the substances given: alcohol, paraffin wax, water, lead, iron. Lead and iron, they are metals. Right? Lead and iron are metals. The others are non-metals, right? So alcohol, boiling point is 77 degrees Celsius, which means when we provide the temperature of 77 degrees Celsius, alcohol starts to boil or it starts to convert to its gas. Boiling point of paraffin wax is 370 degrees Celsius. So paraffin wax, when we heat up to 370 degrees Celsius, it's converted to its gaseous state. Water, we discussed this one. Water, when we provide the temperature of 100 degrees Celsius, up to 100 degrees Celsius, it starts boiling and convert to its vapor. Right? Look at this lead and iron. They both are metals. The boiling point of lead is 1744 degrees Celsius. Right? Boiling point of iron is 2900 degrees Celsius. Which means when you compare these two metals boiling points with the non-metals boiling points, these are very, very high when you compare with the other substances, the non-metals. Right? So after going through this table again, we can come to a conclusion that the boiling point of metals are relatively higher than that of non-metals. So when we consider the melting points, it was the same observation. Right? So after doing this one, we can write here boiling points and melting points. Melting points of metals are relatively higher than non-metals, than the boiling points and melting points of non-metals. Right, children? Boiling points and melting points of metals are relatively higher than the boiling points and melting points of non-metals. Right. So under this extra knowledge part, there's this little part we have to learn. So Celsius scale. So the scale is prepared by dividing the range between the melting point of ice, which means 0 degrees Celsius, we learned that, and the boiling point of water, which means 100 degrees Celsius. Right, boiling point of water in Celsius is 100 degrees Celsius. Melting point of ice in Celsius scale is 0 degrees Celsius. So the scale is prepared, Celsius scale is prepared by dividing the range, which means from 0 to 100 degrees Celsius into 100 equal parts. Right, children? So that's how they calibrate the Celsius thermometers. They mark where the melting point is, the 0th level, where the when you use this particular temperature thermometer, before calibrating it, when you use it, you can find what is the height of the liquid column when ice is melting. Right? You can mark that level as 0 degrees Celsius. And then you can use the same thermometer without calibrating, right? You can use the same thermometer to check the boiling point of water. And that temperature is 100 degrees Celsius. You mark the upper level by that. So between 100 and 0, you have to divide that length into equal 100 pieces. Right? That's how we can calibrate. We can prepare the Celsius scale. Right? So Fahrenheit scale. This scale is prepared by dividing the range between upper fixed point 212 degrees Fahrenheit and lower fixed point 32 degrees Fahrenheit. Now 212 degrees Fahrenheit means the boiling point of water in Fahrenheit. Now this 32 degrees Fahrenheit is melting point of water in Fahrenheit scale. Right, children? Melting point of ice in Fahrenheit scale. So here, this level is divided into 180 equal parts. Okay, children? So that's how we prepare the Celsius and Fahrenheit scales. Okay? So the values of melting point and boiling point vary according to the atmospheric pressure. Earlier also I explained. right? Under the given pressure, it's a certain value, okay? So the values given in table are measured at 1 atm of atmospheric pressure. Right, children? So we have completed this chapter too. So under this chapter, we learn about melting points and boiling points and how the melting and boiling points change when the substances are different. We got a general idea about it. Right, children? So I hope you got a better understanding on this chapter.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.